So I think we start, and my colleague Dominic is going to admit the others who are still joining so that we can make use of this hour. Thank you very much for everyone who introduced themselves already in the chat, and a warm welcome to this webinar on the IPCC Assessment Report 6, Physical Science Basis, which is the report that has been produced by the Working Group 1. With this webinar, we aim to give you the insights of this report and translating its findings for us as development and humanitarian practitioners. Before we start, let me just give you a few technical tips or heads up for this webinar. So we have muted all your microphones by default, given the number of people that we expect. If you have questions directly to Sonia or also to Rupa, please post them directly into the chat. We will address them during the Q&A after the presentations. If you cannot hear or see us, have any problems, you can write it in the chat, but the best is usually to close and restart the webinar and join again. We are recording this webinar, and we'll be sharing the recording through the website of the Swiss NGO DRR Platform. And I also kindly ask you to have your mobile at hand. In the course of the webinar, we will work with Menti, and it's useful to do this with your cell phone. What can you expect today? So I am already in the process of welcoming and introducing to this webinar. My name is Jana Junghart. I am advisor for disaster risk management with Helvetas. And in a few minutes, my colleague Rupa Mukherjee will give an introduction to the IPCC process to provide a basic, let's say, shared understanding of the process and the report structure. And then we come to our main presentation today. Thank you very much, Sonia Seneviratne from ETH Zurich, for joining us and for presenting the major findings from the IPCC Assessment Report 6, with a focus on climate change and extremes. Then you can ask your questions. We will try to address most of them. And then when we are nearing the end of this webinar, we're going to look ahead, what comes next, and close. So before we start with all the content, who is the host of this webinar? So the Swiss NGO DRR Platform, who hosts this webinar, is a network of 20 Swiss-based NGOs. You can see here on the right-hand side the different members of the network. Our mission is to increase the resilience of women and men, communities and governments through an integrated approach of disaster risk reduction and climate change adaptation. And we do work across 3 pillars. So capacity strengthening, learning and exchange, conceptual support, and of course, advocacy. If you want to know more about the platform, please visit our website, drrplatform.org. Why are we as a DRR platform doing a webinar on the IPCC report? When I started to work on DRR about a decade ago, this was indeed a question that you could ask, because back then the communities were rather distinct. Even though almost 90% of all recorded disaster events are climate related, if we follow figures from CRED and the United Nations Office for Disaster Risk Reduction, it was indeed an IPCC report, the special report on extremes that was published in 2012, which brought the close links between the communities working on DRR and climate change adaptation to the fore. It helped to establish a joint framework for analysis, identify overlaps in terms and interventions, and highlighting the relevance of climate change for the future intensity and frequency of extreme events. This is important because usually DRR practitioners, we look back, we establish timelines, etc., to have a good grasp of what we can expect from the future. But climate change changes the game. And when this report was published, this IPCC report in 2021, it came at a time when especially the Northern Hemisphere had just suffered from extremes that were unprecedented. The level of wildfires, the level of flooding, the level of extreme precipitation was in its way unprecedented, especially the compound effects of these events. So we are hosting this event today to give you an insight on the report, on its findings, but also to strengthen the narrative on how can we, or what knowledge do we need of specific events? How are they attributed to climate change? Because this is crucial when we want to advocate for adaptation, when we want to advocate for mitigation and climate action and climate justice. So before I hand over to Sonia Seneviratne for the report presentation, I would like to give the word to Rupa Mukherjee, my colleague and Director of Advisory Service at Helvetas. She's also a lead author of the second working group of the IPCC and is going to guide you briefly through the process. Thank you very much. Rupa, the floor is yours.
Thank you, Jana, and wonderful to see all of you here at this presentation. I will take you through quickly the IPCC process and the process by which the assessment reports are developed. As you know, the IPCC was jointly established by the World Meteorological Organization and UN Environment, or UNEP as it was called then, in 1988. It is an intergovernmental panel with 195 member states. And the IPCC Secretariat is located in Geneva. It works through, it does not do primary research. It commissions assessments of the state of scientific know-how every 4 or 5 year cycle. And this work is carried out through 3 working groups. The first working group does the assessment of the physical science basis, and that's the focus of discussion today. The second working group looks at the evidence of impacts, adaptation, and vulnerability to climate change. What is the state of science? And the third working group looks at mitigation options, possibilities, mitigation pathways, etc. The IPCC does another very important task, which is to standardize processes for greenhouse gas inventories so that the methodology used by different governments are comparable and standardized. So that's another important contribution of the IPCC. In my slides, the working group 2 is always highlighted, but today we focus on the working group 1. Next slide, please. Jana, could you transition?
Trying, Rupa. I just, in my presentation, now it works.
Ah, super, thanks a lot. This is the 6th assessment cycle of the IPCC, and the IPCC produces both special reports, which are at the request of the member states. And this 6th assessment cycle has been very productive and impactful because it produced 3 special reports. The first one was commissioned right after the Paris Agreement, and this is called the Special Report on Global Warming of 1.5. Basically, it answers 2 questions. Is it still possible for us to restrict global warming to less than 2 degrees, which is what the Paris Agreement says? And what is the difference between 1.5 and 2 degree warming? And Sonia was our lead speaker today, was one of the lead authors of this report. It came out with very clear findings with regard to the huge difference that this ½ degree of average global warming can make globally. And it's an optimistic report saying this is the decade of action and it is still possible to do so. The second special report that came out in this cycle was in 2019, and it looked at oceans and cryosphere, which is the polar ice caps, the glaciers, etc., and what is the observed impact of climate change on these. Again, a very important report for all the coastal regions that we work in, all the countries that are dependent on glacial flows, etc. And the third report for implementation organizations like us is also vitally important, which looked at the impacts of climate change on land. And the 5th chapter of this report really looks at implications of climate change on food security, the possibilities for adaptation and land-based mitigation, which has been a huge question. And this report came out in 2019. The work of the working groups, which is on the right side of your slide, was affected by COVID, but it has been a tremendous effort by Working Group 1 to produce its report in an amended timeline. So it came out in August 2021. My group is still working on its final steps, and the reports of Working Group 2 and 3 will be out in the first quarter of 2022. And in this assessment cycle, we also produce what is called a synthesis report, bringing together the findings from the 3 working group reports. The next slide, please. In this slide, I show you the process by which the IPCC reports are developed. So the first step is a scoping, where a group of experts and governments sit together and decide what are the key questions before us at this point when we start the next assessment, what are the key areas where we look for scientific evidence. And that scoping leads to the development of an outline for the reports from the next assessment cycle. This is approved by all the governments, so we are bound by this outline. And then the governments and also observer organizations, many UN organizations, etc., they nominate authors to develop the assessment reports. The selection is done by the Bureau. They try to ensure that there's a good balance of expertise, of gender, of region, and different perspectives come in through the author teams. There are 2 very important moments of expert review where you, as anybody who's a practitioner or researcher, can register as an expert and review the drafts that we are working on and provide us additional information, new references, new things that we should look at. And these happen at 2 specific moments in the IPCC cycle. And there are also 2 rounds of government review, after which what the summary for policymaker or SPM is approved by the government. It's a big step, and for the first time this time, the Working Group 1 SPM was approved virtually, major exercise with 195 countries reviewing every word in a virtual setting. And then the reports are approved and they reach you. So it's a long process, very intensive, a lot of hard blood invested by the author teams. And if you look at the chapter teams, they comprise normally 2 to 3 coordinating lead authors. So Sonia is one of the coordinating lead authors of the Working Group 1 report. Then we have chapter teams of lead authors, 10 to 13 of them, and 2 review editors who accompany us throughout the process, ensure that all perspectives are taken into account, the expert views are seriously considered, the references are included. So they're guiding us, and they also perform a very important sounding board function. An important way to engage in the IPCC process is as contributing authors. You see it at the bottom of the graphic. This is not so demanding, and we get really interesting perspectives from diverse collaborators who may write a particular section or a case study and contribute in small but very meaningful ways. In the last 2 assessment cycles, we've also had the opportunity to include chapter scientists, often young people from developing countries, for whom this is a great experience to contribute through. Next slide, please. With this, I would like to introduce you to Sonia, our key speaker for today. She is with the Department of Environmental Systems Sciences at the ETH Zurich. She's a biologist and then a specialist in environmental sciences. And her work focuses on climatic streams and land-climate interactions. What is very important for me to say is that she was also one of the 2 expert witnesses who spoke up in defense of the climate activists who have been prosecuted in Switzerland. And the fact that the activists use science and science stands up as a witness in the defense of activists gives us hope. And the third element of hope, of course, is action, where all of you come in. So it's great to have 66 of you working at the front lines of DRR, humanitarian response and development, interested in this session. So Sonia, I invite you to address this rich gathering today, and the floor is yours. Thanks.
Yeah, thank you very much, Rupa, for the introduction. It's very kind of you, and it's a great pleasure to give this presentation to all of you. So I will share now my slides. Is everything okay? Okay, great. Yeah, so thanks again to Rupa and Jana for the invitation and the organization. And it's, as mentioned, a great pleasure to give this presentation. So I will present some main findings from the ER6 Working Group 1 report, with some focus also on climatic streams, since this was also the topic from the chapter I coordinated. And I will also present both global and regional findings. Just included those figures, also some pictures of the team who worked on the overall report. As you can see, there were a lot of authors contributing to the report. Of course, the first meetings were in person. You see 2 pictures from a meeting in China and then in France. And in the second phase of the report.
Daddy.
Good morning, Miss Mary.
How's it going?
Okay. And so in the second phase of the report, we basically had to work virtually, but everything worked out fine. And I think that was also a very useful experience, that we managed to finish this report basically with virtual meeting, with, of course, also very little CO2 footprint, which I think is also an important goal for the future. The report is available on the internet. So I will start with some global statistics. And I think the first point about the global warming is that clearly we are reaching some very extreme temperatures. We already had 1.1 degree of global warming in the last decade compared to 1850 to 1900. And so this is, of course, very close to 1.5 degree, which is actually the stated aim within the Paris Agreement. So the aim for as a limit. So warming rate is unprecedented in more than 2000 years. So if you look at the picture here, you see clearly that the warming rate is very large. So we have very strong changes, very short amount of time. And what is, I think for me, also very striking is that the temperature levels that we have reached is unprecedented in more than 100,000 years. So you have to imagine that this level of global warming, having 1.1 degree, might not sound like much, but actually for about 100,000 years, we always lived at temperatures on average that were lower than that, which means that human civilization, agriculture, all developed at temperatures lower than that. So we're getting basically outside the range that we have experienced as a human civilization. In addition to the largest part of this warming is irreversible for several generations. So the main issue we have here is that CO2 stays very long in the atmosphere. Once it's emitted, it stays there for about 100 to thousands of years. Which means that even if we were to stop all emissions, the warming that we have reached now would stay there for a very long time beyond the generations of people living right now. Now, in terms of the causes, it's also very clear why this is happening. And the conclusion of their IPCC ER6 report is that it is unequivocal that human influences warm the atmosphere, ocean, and land. And it's not only that it is clear that we have had a contribution to this warming, but this contribution is more or less all of the warming. So the best estimate of the human-induced global warming until this last decade is about 1.07 degrees. That's about 98% of the observed global warming. So you see on the left figure showing the observed warming, and in brown it's a simulation which includes human and natural forces. You see you're very close to what has been observed. If you remove the human forces, only keep the natural ones, so solar variation or volcanic eruptions, basically you have no warming at all. So it's very clear what is happening is because of human actions. In terms of the CO2 concentrations, there it's also very clear that CO2 concentration has been increasing, and what is even more, this increase are not stabilizing in any way. If anything, it's actually rather exponential. You see here the change in CO2 concentration, they keep on increasing, and the largest measurement ever available is actually from this year. So the highest measured concentration is from May 2021. And you see almost no impact of any decision, or to say, even IPCC reports started in 1990. Unfortunately, we don't see much impact in terms of, inflecting those evolution of the CO2 concentration. And regarding the COVID phase, actually, there was a slight decrease in emissions of the order of 7%. But as mentioned, because CO2 keeps on accumulating in the air, even if you have a small percentage reduction of emissions, you still have an increase in the overall concentration in the air. So you would really need to reach net zero emissions if you want to stabilize the CO2 concentrations. The sources of CO2 emissions are clear. We know this also for a long time. It's mostly burning of fossil fuels. So the main issue is really that we are using fossil fuels such as oil, coal, or gas. And actually this increase, actually if you say anything, this use of fossil fuels is increasing over time. So there is also close to an exponential increase. Land use is also important. Deforestation is also another contributor to CO2 emissions. Now we have a direct relationship between the cumulative CO2 emissions and global warming, as you can see here. This is showing that every additional emission of CO2 is leading to additional global warming. And that's what I mentioned before. So as soon as you emit CO2, the CO2 is going to stay in the air for a very long time. And the more CO2 you have in the air, the higher is global warming. And so you see this clear relationship here in the observations with a direct relationship between how much warming we have had so far and how much CO2 we have been accumulating in the air. And now if we want to stabilize global warming to about 1.5 degrees, really we would be reaching 1.6 degrees in 2030, and we'll have some chance to possibly reduce it up to about 1.5 or 1.4 degrees at the end of the century. We will need to follow this pathway in light blue here, and you see that we have a very limited CO2 budget. So that's basically how much CO2 can still be emitted before we reach basically 1.5 degree. And so this means that we can only still emit a bit of CO2, and after that, of course, we would be outside this range. Now, in terms of observed changes in extremes, so evidence of observed change in extremes has strengthened. That's one main conclusion also of the report. And I was also involved in the SREC report, which was focusing on extreme as well. It was published in 2012. And clearly there we have much more literature. We also have much more events that have happened in the meantime, where we can really say we see a clear influence of basically human-induced climate change. So human-induced climate change is already affecting many weather and climate extremes in every region across the globe. I think that's a really key message of the report. No region is spared from climate change. Every region is affected by climate change, and in every region we see some changes in climate extremes. The climate extremes we have assessed include temperature extremes such as heat waves, heavy precipitation, floods, droughts, storms, and compound events. And by compound events, we mean complex events which either result from the combination of different types of extremes at the same location. So for instance, when you have at the same time dry and hot conditions, which lead to more fire risk, or on the other hand, for instance, also having at the same time different extremes in different locations, which can affect the same sector. So for instance, having different crop producing areas affected by extremes, which can affect global food production. And another important point is that we see that some recent hot extreme events would have been extremely unlikely to occur without human influence on the climate system. So we're starting to see some events where we can say that basically without our influence on the climate system, these extreme events would not have happened. And I would say this is also a very new element that maybe about 10 years ago, it was more like that we had some evidence of an increased frequency of some extreme events. But now the impact on the climate system is so large that we're starting really to see unprecedented events where we can say those events would have had almost no probability of happening without our influence on the climate system. Here I'm just including some events that have been made more likely because of human-induced climate change. Just a few examples, really there would be many more. But some examples include, for instance, in 2019, in France for the first time, temperature of 46 degrees was reached. In Australia, 2019-2020, there were major fires. For instance, in Siberia, for the first time, 38 degrees was reached beyond the Arctic Circle. And of course, there were many other events also in other countries. I took here some examples of events that happened this summer. And so in Canada, basically for the first time, 49.5 degrees was reached and a city was burned down in almost one day. We have seen also very important impact of heavy precipitation in Germany with several people dying. And then in Mediterranean region, there were several fires and very dry conditions this summer. I think what this has shown is that, of course, there are also many developed countries which are affected. So it's, I think those changes in extreme events affecting both developing and developed countries. Now, in terms of what are the observed changes in extremes, I'm going to present what we have in terms of evidence for heat waves. And the main conclusion is summarized in this map. So we have hexagons for different regions of the world. And you see that basically almost all regions of the world show some increase in hot extremes. There are almost none that are spared of this. There is very few exceptions. So we see in almost all regions of the world that heat waves have become more frequent and hot extreme more generally. There is also high confidence that human-induced climate change is the main driver of these changes. So this is very clear that these changes in hot extremes can be related to emissions of CO2 globally. And actually, in addition to that, we also are able to attribute regional changes in extremes. So for instance, we see that we have high confidence, many regions here that changes in hot extremes can be even attributed on regional scale. So we have high confidence regarding the attribution on regional scale. Another change that is important is changes in heavy precipitation that also mostly affect a large number of regions, but for instance, also several regions in Asia. And we see from observations, wherever we have some color here, this shows that we have an increase in which we have at least medium confidence from the observation. And so you see that several regions are showing an increase in heavy precipitation. The reason for that is that when you have warmer air, the air can entail more moisture. So when you have precipitation, it's much more intense. And so the assessment is that the frequency and intensity of heavy precipitation events have increased over most land area for which observation data are sufficient. So we see that there are a few regions where we don't have enough data, that's shown here in gray. And most of the reason for that is in case of heavy precipitation data, we are looking at short-term events where we need daily data. And so for some of the regions, we don't have enough daily data. But for those regions where we have enough data, you see that the majority of them are showing an increase in heavy precipitation. So the other conclusion is also that human influence, in particular greenhouse gas emission, is likely the main driver of this observed global scale intensification of heavy precipitation and land vision. So on global scale, for those regions where we see an increase, the assessment is that likely the human influence is the main driver. On regional scales, there is sometimes more noise, so it's more difficult to attribute it, but we can say collectively for most regions, we expect that human influence is the main driver. As mentioned, we had also some substantial assessments for changes in droughts. And in the report, we looked at different types of drought. So we looked at changes in just precipitation-based drought, where we have lack of precipitation, which is called meteorological drought. And then also agricultural and ecological droughts. This is then looking at how much water we have in the soil, which is relevant for ecosystems and so agriculture. And then another third one is hydrological drought. This analysis here for changes in agricultural and ecological droughts, for which we have a clear sign of increase in many regions. So from observation, we see that several regions show an increase in agricultural and ecological droughts. These are all the regions which are indicated in yellow here. And in some of the regions, we can also attribute it to human influence, particularly in the Mediterranean region in Western North America. So the assessment is that human-induced climate change has contributed to increases in agricultural and ecological droughts in some regions due to land evapotranspiration. So that's an important point. Precipitation is generally more variable, but what we see in many regions is there is a tendency to have more evapotranspiration. And that's also related to the fact that the air can take up more moisture. So if it's warmer, which means that it can dry out the soils, and that's an important driver for this drying. So we have also some other assessments, for instance, for tropical cyclones. The conclusion there is that it is likely that the global proportion of major tropical cyclones, so category 3 to 5, has increased over the last 4 decades. So we see not necessarily an increase in the total number of tropical cyclones, but amongst all tropical cyclones that happen, there is a higher proportion of these intense tropical cyclones. Human influence has likely increased the chance of compound extreme events since the 1950s. So the most complex events, the fact that you have several different types of extremes, happening at the same time, either the same location or different location. We find in particular that there is high confidence that there has been an increase in concurrent heat wave and droughts on global scale. There is also an increase in fire weather in some regions of uninhabited continents. And that's also related to the compound dry and hot conditions. And we have also an increase in compound flooding in some locations. That's particularly the case in coastal regions, because there you have the combined effect of increase in heavy precipitation and increase in sea level. So what will happen in the coming decades, to a large extent, really this depends on our decision now. It's a really important point to basically communicate. And so if, for instance, we're interested in what is going to happen in the next 9-10 years, so about, that's for the midterm, so the 2050, you see that for 2000, in the near term, 2030, we would be reaching about 1.5 degrees. By 2050, we see really a change between the different emission scenarios. And so if we follow the best scenario here, we are able to more or less stabilize global warming at around 1.6 degrees at that time. But then if we emit much more CO2, we would be at much higher warming levels. And at the end of the century, we would have very clear different scenarios with the best case about 1.4 degrees of global warming, in the worst case more than 4 degrees. So these are the projections of these different scenarios that we considered in the IPCC AR6 report. And you see the projections for changes in carbon dioxide. And you see that some scenarios, well, even still have really major emissions. On the other hand, if we want to follow a scenario that is compatible with the Paris Agreement, we have to follow this light blue scenario here, which has immediate reductions in CO2 emissions. And so that's what the outcome for those different scenarios at the end of the century. So as mentioned, only this scenario here, this light blue scenario, allows a stabilization at around 1.5 degrees. And of course, in the worst case, we would be much above 4 degrees, and it could be even reaching more than 5 degrees. At the moment, we are following a pathway that is rather bringing us to 3 degrees. And as I will show, actually already at 2 degrees, we would have major impacts compared to 1.5 degrees. So we should really have much more ambitious mitigation. So what will happen next regarding projected changes? What we find is basically we find a direct increase in changes as function of global warming. So a lot of the analysis we have in the report for extremes is a function of global warming. And so we find that many changes in frequency and intensity of climatic streams becomes larger with increasing global warming, in particular for hot extremes, marine heat waves, heavy precipitation, agricultural and ecological droughts in some regions, and the proportion of intense tropical cyclones. And we already have much higher risk at 2 degrees compared to 1.5 degrees, and as well at 1.5 degrees compared to now, including some irreversible impacts. So I think that's a really important point to remember. I mean, already now at 1.1 degree, we are already having impacts. We have people who are dying of climate change. We are having major impacts also on ecosystems. At 1.5 degrees, it will be worse than now. And then, of course, at 2 degrees or more, it will be even worse. So everything that every additional warming we can avoid is impacts that we can avoid as well. So I'm just illustrating some of the material that we have in the summary for policymakers regarding changes in extremes. And that's about the change in frequency and intensity of hot extremes as function of global warming. And the main message is that the changes are larger, both for frequency and intensity, with every additional increment of global warming. And here this is illustrated in part for 0.5 degree, but it's really any additional warming lead to more change in extremes. So if we are looking at hot extremes here, we are looking at an event that would have been happening about once every 10 years in a climate without human influence. Well, we already have substantial change now. So such an event would be happening at about 1 degree, so more or less present climate, about 3 times every 10 years. So its probability is multiplied by 3. Then at higher levels of global warming, for instance, at 1.5 degrees, such event would happen about 4 times out of 10 years. Now, if we go even further at 2 degrees, you see that such an event would happen almost every 6 times out of 10 years. And at 4 degrees, basically almost every year you would get such an extreme event, so an event that was considered extreme before. So every additional half a degree of global warming causes clearly discernible increase in the intensity and frequency of hot extremes, including heat waves, and that's assessed as very likely in the report. Now, another important point is that the change in frequency is actually higher for rarer events. And I'll illustrate this for an event that would have been happening once every 50 years. So if you take an event that was really very rare, would have happened only once every 50 years without human influence. Well, such an event has a much higher probability now. Its probability is multiplied by almost 5 compared to 3 for the 1 in 10-year event. So you see that the increase in frequency is higher for these rarer events. And at 1.5 degrees, it would happen almost 9 times out of 50 years. So basically once every 5 years. And then at 2 degrees increase further. And it's that at 4 degrees, similar to what you had here, basically it's happening almost every year. So most of the years are showing this type of condition. So the projected changes in frequency are higher for rarer events. That's also important. This means that you get really much more probability of having these events that would have been considered very improbable without human-induced climate change. In terms of the change in intensity, hot extremes on land warm more than global mean temperature. That's because the land temperature is increasing more in general. And you have actually in some regions, this is average over all land area, but for some regions, the changes are even larger. But what you see here, average on all land areas is, for instance, at 1 degree, you have actually an increase on average of 1.2 degrees. But of course, in single events, it can be much more, as we have seen, for instance, in Canada. So now regarding changes in heavy precipitation events, it's very similar. You have also here the change in frequency. And again, if you are looking at a 1 in 10-year event in the climate without human induced climate change, this event would be more frequent now, would happen about 30% more frequently than without human-induced climate change. And this increase in frequency is further becoming larger with increasing global warming. Another really important point, particularly for heavy precipitation, is a change in intensity. There is very strong. So at 1 degree of global warming, we have an increase in intensity of about 7%. And for any additional warming of 1 degree, we get another increase of 7%. So that's why in this case, we're also getting really events that are much more intense. And that's really important for impacts. Regarding droughts, so the statistics I've shown for heavy precipitation and temperature were average over the whole land area. For droughts, we find that there are some regions which have a tendency towards drying in projection. And these regions are shown here in this map. So these are all regions for which we have at least medium confidence that there is an increase in drying at about 2 degrees of global warming. So it includes several regions, 2 regions in Europe, including the Mediterranean, so also Northern Africa, part of Southern Africa. But as you see, for instance, South America is very strongly affected with several regions with increasing drought, North America and Australia as well. And we have the same type of statistics that the frequency of those events, those drought events, are increasing with increasing global warming in those regions. And their intensity is also increasing, which is indicated here with this metric. So I come to other conclusions about changes as function of global warming. For compound events, we find that, and more generally, all changes in extremes, with further global warming, every region is projected to increasingly experience multiple changes in climatic impact drivers, including extremes. So basically, with increasing global warming, you don't have only change in a single extremes, but many regions are affected by multiple changes in extremes, which, for instance, in the case of Central Europe, includes change in temperature, heavy precipitation, and droughts. But many other regions are also affected by multiple threats. If you think of coastal regions, they are also affected by sea level rise. Many regions are projected to experience an increase in the probability of compound events with higher global warming. And this is particularly the case for concurrent heat waves and droughts, which are likely to become more frequent. And also the fact that we have a further increase of fires and compound flooding. Concurrent extremes at multiple locations also become more frequent, including in crop producing areas at 2 degrees and above compared to 1.5 degrees. And I think this is a lot of concern also, in particular for humanitarian considerations, because of course, if food prices, if you have more food shortage, you would have an increase in food prices, and this could have substantial impact. So again, with increasing global warming, you have more risk that you would have shortage of food production on global scale. So I come to the scenario for stabilization. What should we do if we want to limit global warming to about 1.5 degree? And there I'm coming back to the 1.5 degree report. The scenarios are actually the same. And they have similar values in terms of remaining CO2 budget. So regarding the evolution, what we see is that the stabilization to 1.5 degree requires changes which are unprecedented in terms of scale. So we have seen before this, almost exponential increase in emission. What we need to have is really basically decrease right away emissions, and we will need to reach about a halving of emissions by 2030. And then we need to reach net zero CO2 emissions at the latest in 2040. Or 2050. And there, I think it's really important to communicate, because sometimes we hear this kind of goal of having net zero in 2050. Net zero in 2050 only gives us 50% probability that we can stabilize global warming to 1.5 degree. So if we want to have more probability, we will need to reach net zero in 2040. This gives us 2/3 chance that this could work out. So to come to the conclusions, evidence on effects of human-induced climate change and extremes has strengthened in the past decade. And we see that no region is spared from changes in extremes. Unprecedented events become more likely with increasing global warming. And also stress from extremes are multiplying with increasing global warming. So we're getting more change of different types in extremes. And so of course, in the same region, you could have 1 year change in hot extreme, but then the other year, a change, for instance, heavy precipitation, and this needs also to be considered. Risks we will be facing beyond 2030 depend, and also beyond for the rest of the century, depend on current decision and actions. So we could have a world at 1.5 degree, and I think there is really important to communicate that basically this world could be a nice world to live in. We have alternative energy sources. We could, move to renewable energy instead of using fossil fuels. And of course, it would be nicer than a world with higher global warming, because we would be less affected by extreme events and disasters. But to achieve this, we need to have a reduction of 50% of CO2 emissions by 2030. And so compared to now, this would mean decrease of about 5 to 6% per year. Also, we see that numerous risks become much larger above 2 degrees, such as for instance, there is much more risk of species extinction or having concurrent extremes in breadbasket region. And I'm happy to answer more questions on this in the discussion session because there is substantial material on this question. So to come to my conclusion, we should do all we can to limit global warming to about 1.5 degrees and avoid overshoots on having too much higher warming compared to this. And I would say even a world at 1.5 degrees is not safe, but it's the best option we have. Yeah, thank you for the attention.
Thank you, Sonia, for this very rich presentation with a lot of insights. I can literally see the participants thinking hard about which question to ask, and you still have time to put your questions in the chat. So far, we have received 2 questions, and I will read them. So Andreas from Welthungerhilfe asked, what is the margin of error for these models? Are we going to have other models in 5 years that are showing worse outcomes? Can we expect that?
Yeah, so I would say those results are quite robust. And for instance, the conclusion of the ER6 regarding changes in extremes is quite consistent with the conclusion we had in the 1.5 report. So I would say in terms of this, it's certainly that much more robust than what we had at the time of the 1.5 report, and they go in the same direction. So I expect these results are robust, but where we have some remaining uncertainties is indeed maybe in terms of the possible bad scenarios. And there, on the one hand, I think this question of compound events, this is really an emerging topic. There is emerging literature which is showing that this is very important to consider. And there is still a bit too limited literature. So I think we would need more. So there, I mean, the impact on food production is just one example, but you're thinking of all the possible supply chains that can be affected. I think the impacts could be substantial, and we are still missing maybe more detailed literature on that. Another topic which could be maybe worse than what we assessed so far because of lack of literature and also still evidence is the whole question of tipping points. So that's, of course, global scale potential impacts of instabilities in the climate system. We know that there are potential tipping points. The assessment of the 1.5 report was that it's unlikely that we would reach such a tipping point below 1.5 degree. But some models, some studies show a higher probability of tipping points between 1.5 and 2 degrees. So I think in coming years, we might see, you know, if some of those tipping points seem more likely based on the observed data.
Thank you. I don't see a follow-up question regarding this one. Another question is on, let's say, the impacts of the COVID-19 lockdowns and the reduction in emissions in 2020. Did it have a measurable impact on climate change, on warming, on emissions? And if so, how can the impact be expressed?
Yeah, so as I said, I was showing the change in CO2 concentration. So this was only up to 2020, but we have now also measurements from 2021 couldn't be included in the report because we had to finish all the main assessments in February. But as mentioned, the latest measurements show an even higher concentration. Now, this shouldn't be surprising. So there was a slight reduction of emissions really during the period of most lockdowns. It was about, I think, 20%, but afterwards, if you average over the whole year, I mean, there was a quick return, you know, of the economy, more activity very soon. And of course, there are also a lot of emissions which are happening no matter what is happening in terms of mobility. So all the emissions associated with heating or industry processes, they kept on happening. So the overall decrease in 2020 was 7%. So it's not negligible, but in the end, for the CO2 concentration, it still meant that you had a very large further input of CO2 in the air. So you cannot say, I mean, again, the net effect of the year 2020 was a further worsening of the situation because we have higher CO2 concentrations than before. So the only solution is getting to net zero. You really need to have more CO2 input to the air.
And we have two more questions. Sophie asks whether it would be possible to inform, or she asks, would it be possible to inform consumers on globally traded food commodities produced in climate vulnerable areas, the ones that you mentioned related to high probability of agricultural and ecological droughts, through standards, labels, etc.?
Yeah, I mean, that's a good idea. So I think having more labels would be very useful. Some climate specific labels. So, I mean, you could have some labels saying that the product is organic, but actually required a lot of energy. So I mean, you need a different type of label that takes into account impact on climate. So you could have maybe a label that is showing how much CO2 emissions is associated to the production of those these products. And so you mentioned also water stewardships. Definitely water is another also very limited good. So I think, yes, there is potential for really improving communication. And just to take the example of Switzerland, which I know best, our emissions in the country are about 4.4 ton of CO2 per person. But if you take emissions associated with consumptions, it's 3 times more. It's about 14 ton per person. So a lot of emissions are indirect. You don't think of this, but it's through consumption. Yeah.
Thank you very much for this nice transition. This leads us directly to the next question by Melchior. who have that impacts and emissions often do not come from the same country, and we can also think about these indirect emissions that we have. Do you, for example, expect the US as heavy emitter to really change course? And yeah, also under the impression of present US droughts and fires and so on.
Yeah, definitely. So I would say, yes, some countries are more strongly affected, and certainly developing countries are at risk because they have maybe less means for adaptation. But I think from this summer, you see also that both developed and developing countries are more in the same boat, because in the end, there is only so much you can do with adaptation. I think that if anything, this is, to me, one thing that has been shown really with those events, you had major impacts in Canada. Many people died of the hot extremes there. Many people died in Germany. And maybe that might lead to a better realization also in developed countries that they are not going to be spared by climate change. And since they are the main emitters, but maybe realizing they are also affected by not only developing countries are affected. I think this message can be also a little bit counterproductive if you insist too much on impacting developing countries, that then developed countries think they are the main cause for this, but they are like, okay, we are not going to be affected by it, so we don't want to do anything about it. And I think it's important to see even developed countries are affected by this, so it's in their interest to stop emissions. And I guess from as far as the US are concerned, I'm waiting for the COP in Glasgow to see what happens, but at least Joe Biden has said that he wants to have more decisive climate action.
Okay, given the time, I think we can at least take 2 more questions. So, attempts on the part of vested interests to deny climate change. Have you any experiences of particularly good ways to counteract climate deniers?
Yeah, well, I think there is a lot of literature on this, a lot of evidence that, I mean, just to take a few examples, that Exxon actually knew about climate change a long time ago. They had even scientists which predicted the correct evolution of global warming. Their prediction for global warming in 2020 is exactly identical or with what the Exxon scientists expected in the 1980s. So yes, we know that there was knowledge in the industry, and that also there was some active climate denying that has been done. Now, about what we can do to counteract this climate denial. So first, I think we just have to repeat the evidence, repeat the facts, share the IPCC report, share this evidence. I think one point is also on propaganda, and I mentioned that. I think that, on the side of climate deniers, they are trying to give the impression that climate scientists are alarmist. And if anything, I think we're not alarmist. As I said, maybe there are some things that could happen that are worse than what we have because we have uncertainties there, like for tipping points. But on the other hand, I think there is some alarmism that is being done, and it's regarding the solution. It's painting the fact that we would not be using fossil fuels anymore is something that is very hard, that would have huge consequences for our well-being. And I don't think this is true. I mean, we have other ways to have energy, for instance, from renewables, and especially in developing countries. I think it would really make sense to just leapfrog to shift to have major use of renewables. And there we should also think about the other added benefits. So for instance, when you burn petrol, not only, of course, you emit CO2, but you emit also pollutants, air particles, which are very bad for health. And lately, so maybe that's a good argument, some journals from the health sector, so health journals, have basically made a call for limiting global warming to 1.5 degrees. And they said it's basically the impact on health are major if you go above 1.5 degrees. And also the costs are major. So there are major costs associated with this.
Thank you so much. I would like to pick out one question because I think it's quite important to understand the conclusions from the report rightly, which is it's related to the notions of likelihood, likely, most likely, more likely, of the findings related to extremes, for example. And Annette asked whether she understands it's right that this is because of missing information, or is it because of contradicting information from research results? So what can we as lay persons or how can we work with likely, highly likely notions?
Yeah, I think maybe that's a failure from IPCC to focus so much on different levels of confidence. In the end, likely or most likely, all of this becomes in the high confidence range. So any statement where I say it's either likely or it's very likely, these are basically statements on which we have, high confidence. And we had with some colleagues recently a paper where we discussed, what would be the legal implication. In fact, in courts, often what is requested in terms of confidence is just being above 50%, that there is basically the balance of evidence points in the direction. And there actually any statement from IPCC, even medium confidence, would be relevant. So I think maybe from IPCC, by focusing so much on those different levels, we give the impression that there are uncertainties, but you should think that, for instance, very likely means there is 90% probability that this is, correct. So there is very few chance that it's not correct, and likely would be 66%. So, any statement with likely, most likely, high confidence means, scientists think this is true.
Okay, I think this is a good way to close your presentation. Thank you so much. And so before we are closing this event, I also, of course, have some questions to you. And for this, I would like to ask you to go to menti.com and to enter this code. To get a better understanding of how you perceived the presentation, the findings, and what you take away from it for your work. All right. Which are the most important takeaways from the webinar? Does it work for you? Yes, the code is this one. I post it again. Can you just indicate if you can see the slide? Can you see the Menti results?
I can see your slide.
Okay, great. Okay, good. Okay. So we have a very strong evidence. We have to act now, of course. Sometimes this is easier, sometimes it seems more challenging. Yes, we have evidence now that climate change is human-made, and actually the report states that it's unequivocal. So it's not just evidence that climate change has a human contribution, but that what we see, as Sonia said, is because of human action.
Yeah, and this is a case of a statement of fact. So that's probability with 100%.
Yes, thank you for this clarification. Okay, and we can go further to the next question. Which is more related to your personal work, because findings are one thing and science is also one thing, but we working mostly in development cooperation, humanitarian response. How do you think you can incorporate some of the report's finding into your work? What changes or what changes does it, can you or does it have changes for the way that you do your work, you plan your projects, you incorporate climate change? Yes, I see here very concretely water use efficiency measures for these 10 and 50-year scenarios. I also found this information really important, that we that even maybe from the DRR side, we look back to what we have experienced, and with climate change, we have to multiply this. Of course, we cannot use the data for every context that we work in, and sometimes there is not all the data yet there, but we know we can expect more of those extremes and even new extremes that we haven't experienced before. Yes, communicate the findings in the knowledge products. Yes, integrate climate change focus and development projects. Definitely screening where possible, implementing and being aware of what extremes and also slow onset changes, how they may impact on our projects. Yes, one person also mentions the personal life. I think it's both. Huh? Great, thanks a lot. We will use your findings or your feedback. We will incorporate them into a brief report on this event, which you will also find on the website of the Swiss NGO DRR Platform. And so now, before we fully close, I would like, so we have this, to give you a heads up of 2 upcoming events from the DRR platform that might also be relevant. One is a face-to-face learning opportunity on the gender dimension in disaster risk reduction, which takes place end of November in Bern. And for those of you who are not based in Switzerland and are interested in virtual learning related to climate finance, the DRR platform is also hosting a climate finance webinar series. And on the 26th of October, the initiative or this webinar series will be around the German International Climate Initiative, ICI. And to all of you who found this webinar interesting now, we are going to continue this webinar series on the assessment report 6 in 2022, especially when the working group 2 and working group 3 reports are out. If you would like to be informed about upcoming events, I also invite you to go to our survey, post-event survey, so that you can, and I will post the link here in the chat, so that you can become part of our newsletter and be informed about any upcoming events, particularly, of course, if you're interested in this webinar series on the IPCC reports, then you can indicate this also in the survey. Okay, it's 1 p.m. Some of us may be hungry. And Sonia, thank you so much for your time, for the rich information and also the interpretation of the findings that you shared. For me, there was a lot of relevant information that that will guide my work in the coming time. Yes, Jane, yes, you say it's a gloomy evidence, but still let's focus on that, also on the positive aspects. Like, let's also focus on the possibility to act. So Sonia, thank you very much, and thanks to everyone for joining us in this event. We will make the report, the recording, as well as the slides available on the website of the DRR platform. And everyone who has registered for this event, I have your email ID, so I can get in touch with you once these elements are uploaded to the website of the DRR platform. And with this, I would like to thank you and close with a small cartoon. The spirits say, you have all the data, so now just do something. Have a good afternoon. Have a good weekend. And take care.
Thank you. Bye.
Thank you, Sonia.